Okay, so we're back. Modeling floors, ceilings, and roofs in REVIT 2020, Build 2. We talked a bit about understanding the floor types. I wanted to reiterate a little bit more. Elasticity of the materials and permeability of the materials. However, let's get into the physical aspect of it, or the thermodynamic aspect of the materials at another time, because we could spend years just talking about that. I don't get in trouble, I'm smoking. All right, so we're going to get into the actual modeling of these floors. And we talked about the collaboration and the ownership of floors. Now, all kidding aside, whether or not you are working under an integrated project delivery IPD contract, the so-called ownership of floors should be carefully considered for the collaboration process between an architect and a structural engineer. Floors can be one of the most contentious elements of a building design because they can be simultaneously construed as architectural and structural. I want to turn this audio down just a little bit on the it's a little late for that, but I'd like to mic down a little bit. I'm just going to have to speak a little smoother and lower my pitch, my tone. It's too late. Well, I'm sure it's not, but I could move away from the mic. All right, so the model element author, MEA, for floors should be discussed and clearly defined for each phase in your project. Phase 2 is starting on Monday. Okay? Remember that element ownership can pass between the architect and the structural engineer when it is appropriate for a given phase. For example, the architect may choose to be the MEA for floors in schematic design, but pass ownership to the structural engineer in design development and construction documentation. And there'll always be a job for you if you can provide construction documentation. Detailing is always a need for a detailer. Now, let me have some coffee. With a basic understanding of floors as elements of the building, let's look at some properties of floors and allow expanded uses in the project model. These properties and floor types can help expand your use of floor systems to create better documentation. Better documentation. Now, I have the systems browser open. I also have the project browser open. At the same time, on a tabbed scenario. So now, once this open up, Chapter 14 Floors Start, or the metric version of that. Now, I have that open. I've tiled a lot of views, and I also still have the curtain wall, them, opened up, the RVT of that. So, yeah, let's take a look. I got the inspection view open, as you can see, I've been playing with. And you can see that is indeed in the 3D perspective 3D we have. We don't have that open. We have open the north elevation. We have open a section 1, which is a longitudinal section. We have open the west, the east, level 3, and level 1. And this is the top view of them, of the curtain wall with the mullions and the panels. And we talked in the last chapter about how we can create complex wall systems. So that being said, I just want you to orientate yourself before we get into this to the views. I mean, I know we've flown through this, and the book really doesn't spend nearly enough time. And they're going to get right into the shared coordinates and project coordinates and base point and survey point soon. And I don't think it takes enough time to really get you focused as you have all these windows open, because it can be very perplexing. Now, again, nonchalance is the key to this. If you're getting spun in 40 million different directions at your job, and you're not producing anything, you have to really do an engineering review and a quality a QC. You always do an engineering QC on the engineering practices. That's part of the course. And then I just figured that out. That makes sense, right? All right, so Okay, so let's just get an idea of which way we're looking, okay? Now let's just I'm going to tile the views for a second. I already tiled them. I'm going to just put them in a tab format. Let's take a look at the 3D view. Let's look at the view cube. You can see north is as per north, right? True north. Project north. Things you're going to have to think about later on. But for all intents and purposes, I think everyone gets a general idea that west is this way, east is that way, south is this way, in this particular model's perspective. Its attitude. So let me tile these views and make a note of that. The CA, all of the viewports, so zoom extents, centers all of them within their own respective viewport. Now, when I zoom in here, you see this tree I put in here, this tree? When I select it, you can see that it's selected in multiple views. It's selected in the west view. It's selected in the east view. It's not selected in the east view. You can't see it, right? You can see the one on the side of the east view, but you can't see the one in the front of the building, right here, on that side. So now, if you remember, that would be looking from the west. Looking from the west, as if you went out west from New York City and you turned around and you came back during in the 1700s. So now, if you have to understand that when it comes to architecture. Everywhere you look, there's going to be an elevation symbol or a section symbol depicting an arrow in which way you're looking. And it's just it's a diagrammatical note. It's an annotation, it's an articulation on the drawings. So if you look in level 3, and this exists in all the levels, you'll see there's a section line in here. It's not placed on a sheet yet, so it doesn't have any sheet number, view number, section number, because if you put multiple sections on a sheet, then you can number them, and it'll remember, so you don't have to keep typing it in over and over on every view that references that section cut. And I only bring this up because I've been in a lot of companies where it's not registering. It's just not registering. It's falling on deaf ears. And I've been around the block to know. I swear, God's my witness. I won't succumb to the AutoCAD MEP disease. All right, so I just wanted you to get that understanding because we're going to be getting a little more in depth. We're going to be working within the confines of the sandwich of the building. And in those sandwiches exist all of the systems that are required to keep these buildings green, right? All of the systems, mechanical systems, electrical systems, waste systems, financial systems, all sorts of systems. There are so many systems in the system, and then there are systems on top of that. System after system after system. Captain's log, start date 2020. Captain. Hey, Captain. How many captains are there? Anyway, I'm down in engineering with Scotty. So I just wanted you to orientate yourself to that. Because we'll be creating a structural floor. Now, the structural floor is similar to a traditional floor, but has structural functionality, such as the ability to indicate span direction and to contain structured profiles. For example, you can specify a composite metal deck profile which will display in sections and details generated within your project. You can create a structural floor by selecting the floor element and clicking the instance property called structural. Because structural is an instance property, any floor type can become a structural floor. After you select the structural parameter checkbox for a floor, you can edit its type, properties to add a structural decking layer. Let's create a new structural floor so you can explore how this is done. Open the C14 Floors Start RVT or the metric version from the Books Companion website and activate the level 3 floor plan, which we have activated. Let's tab our views. This is double click down on the mouse wheel. And now we have our level 3. Let's go to the project browser, and you can see within the project browser level 3 is highlighted. Go to the Architectural tab, and we're in the Structural tab. Oh, we're in the View tab. The Structural tab is so much more. For you gearheads out there, any propeller head. It's just not give you the chills. All of these beautiful tools. It's like going to Home Depot. It's a virtual. It's like having your own garage and just having whatever tools you want at your fingertips. It really is. If you're a man cave kind of guy, and again, I don't want to come off as being a male chauvinist pig, but I really like these tools, man. I don't know if it's just me. There's something about tools. It's programmed into our DNA, I think. I don't know. Anyway, so yeah, go to Architectural tab of the REVIT, and from the Build panel, select Floor Structural. From the Build panel, select Floor and Floor Structural. Notice what we had, though. We had a bunch, right? We had a bunch, and we should always take the time. This is what you got to do in this program. Floor Architectural, MEA, right? MEA, Model Element Author. Who's going to take ownership of it? Architectural floor. We have the structural floor. Okay? And when you go through all of these instructions, floor by face converts a mass floor into a floor of the building model. Now, we talked about masses, and we talked about revolved surfaces. We talked about extruding. We talked about swept blends. We talked about all sorts of different geometric ways that we can build from geometric primitives and basically apply the helix to it, apply a worm gear to it, twist it and contort it, torsion, tension, all those things that we can program into this to give us the analysis that we need, or the analysis that's demanded from the industry by legislative compliance, right? And then you got floor slab edge, shapes the horizontal edge of a floor slab. Now, we can't get into all these methods right now because we're gonna. And with me, if I could, show you all the tools at once, I would, and that's not good. And I'm guilty of that. So, let's just go through it, okay? So go to the Build panel in the Architectural tab, to the Floor Structural. In the Draw panel of the Contextual tab in the ribbon, make sure your options are set to Boundary Line with Pick Walls tool. Well, there's the Draw panel within the Contextual tool bar ribbon that opens when you invoke the Structural floor command. Make sure that Boundary Line is set, which it is. Pick Walls tool is activated, which it is. I'll read it, what it says. Adds sketch lines based on existing walls. Sketch lines created using this tool are automatically constrained to the walls. To select a chain of walls, move the cursor over a wall. Press tab to highlight the entire chain and click. Sounds pretty sadomasochistic to a certain extent. It does. It does sound a bit sadomasochistic. Boundary line. Well, again, whatever blows up your skirt. Sorry, this class is for 3-year-olds. Who on the Belmont? Is it post time yet? In any event, this class, obviously, use your better judgment. All right, so in the options bar, specifying, now this is very, very, very important. Make sure your options are set to Boundary Line with the Pick Walls tool. In the options bar, and this is the options bar, right? Specify an offset of 0 feet, 3 inches. This setting will place the floor boundary just within the inner face of the curtain wall mullions, because the location line, and we talked about this, the location line of the curtain wall is at the center of the mullions that are 5 inches or 125 millimeters deep. By picking the exterior curtain walls, begin picking the exterior curtain walls by selecting one of the north-south oriented walls first. So if we zoom into this wall, notice the curtain wall selection line, but notice within the options bar, you'll see extend into wall core, right? Now we see when we hover over this, there are 2 lines highlighted. So now prudence dictates that before you even start selecting walls, you escape out of the command. You escape out. You go down to the wall again, this curtain wall, and you select it, and you look. And you say, okay, well, curtain wall storefront, if you see its location line, you'll notice that the center of the mullions are 5 inches deep. So if I was to give you a dimension, we could actually test that, right? To the center, wall center line, right? So now, if we're going to go to the location line, just come down. Well, that is 1'3 1/4. And that's one way of doing it. And then there's another way of doing it. You measure 5 inches. Okay? So we place this floor. You'll see in elevation just how the floor is going to align with the mullions and give us maybe just a 1/2 of an inch difference between the two. And it's a lot easier to show you than it is to lead you along. So let's just remember that. So let's go back to the architectural tab and invoke through the build panel the floor structural. And in the options bar, or in the contextual toolbar, first make sure boundary line and pick walls is selected and offset at 3 inches. Extend into wall core. Give that a second, and so something's threading in the background. Okay, so begin by picking the exterior curtain walls by selecting one of the north-south oriented walls first. So I'll select this one. As you can see, you get a little span, a flip arrow, and this is going to dictate the span. The first wall that you pick will determine the span direction of the structural floor. You can change this at any time by picking the span direction tool from the draw panel, which we may have to. If you remember, the span that we looked at had multiple structural members in multiple different directions. Joists, if you will. Beams, columns, stiffeners, load-bearing walls, things of that nature. So the span is going to play a huge part in this. It's going to dictate the rebar direction. It's going to dictate thickness. It's going to dictate a lot. Thickness varies, not just floor by floor, but within a floor, on a floor. These topping slabs, these floors they're unique in most cases. It's not as cut and dry as you think. So, begin by picking the exterior curtain walls north or south. I selected the south. The first one you pick will determine the span direction of the structural floor. You can change this at any time by picking the span direction tool from the draw panel and then selecting one of the boundary lines in the floor sketch. And we can do that. Span direction. And will there be a video? No. Specifies a boundary line of a structural floor to which metal decks will run parallel. The span direction symbol is placed with the structural floor. The metal deck and its symbol are specified by this initial placement and can be later modified. So let's just hold that thought. But we're not there yet. This still has to go to the structural engineer. We're not licensed to make these decisions. However, if you know the right people, you'll be fine. Not saying that I'm going to start dropping names, but listen, if you know a company that does something and it's a service, then utilize it. I'm not going to just start giving shout outs. But I've went out hooting with the owls at night. Oh, no doubt. I apologize. But I've also soared with the eagles in the morning. So I'm guilty of a lot of things, but paying attention and trying to better myself and my craft isn't one of them. Or I'm in the process of it. So, speaking of structure, after you finish defining the boundary lines of the floor, well, first we have to pick the remaining exterior walls to complete the floor boundary. So let's just go in a clockwise direction. Click that one. Pan down, move over, click that one. Pan down, click over, and click that one. After you finish defining the boundary lines of the floor, you will create a new floor type. If the Properties palette is not open, it is. Press Control 1 on the keyboard or type PP, or click the Properties icon in the ribbon right here. But it's open because we're not done yet. We're still in the context of the command, conveying it. Click Edit Type in the Properties palette. Select Generic 12. Or generic 300 millimeter, depending on what side of the pond you're on, as the active type, or if you're talking to a machine, as the active type, and click Duplicate. Generic 12-inch active type, duplicate. Name of the new type Structural Slab. In the Edit Type dialog box, click the Edit button in the Structural row to open the Edit Assembly dialog box. Now, this is just like the stacked walls and the basic walls, remember, with the layers. It's the same interface. It's the same interface, and it gives us a preview, just like the stacked walls. Isn't that a beautiful thing? Isn't that a beautiful thing? Okay, so I'm getting the chills. I'm getting the chills. It's like 80 degrees in this apartment. I can't even turn the HVAC unit on because it has some condensation issue. My landlord is like oblivious. In any event, speaking of environmental engineers, whatever. All right, so yeah, we got this beautiful blank canvas of the floor that we can now add different layers to it, like we did with the other exercises. So this is where, you can start to develop your sill details and all of that. How this is all going to intermesh. Floor, ceiling, foundation slab, foundation wall, grade beam, all these things. How it copes with the structural members. Now, in the Edit Type dialog box, click the Edit button in the Structural row to open the Edit Assembly dialog box. In the Edit Assembly dialog box, find the layer of the assembly that represents the generic floor you duplicated. This should be row 2. Change the material of this layer to concrete, cast in place concrete, and change the thickness to 6 or 150 millimeters. Well, now that is cast in place. That's going up the material browser, and it should be right in the front, right? Concrete cast in place. Come on. Sometimes it's easier. Cast in place, right there. Sometimes you can just search up with a couple letters like anything else. In Lotus Notes, if you remember. In Lotus Notes. Netscape Navigator. I'm sorry. Am I waxing nostalgic? I apologize. All right, so yeah, before I go off on a trip down memory lane, we have the assembly box open. We're going to change this to concrete cast in place and change the thickness to 150 millimeters. So now, notice in the material browser, there isn't anything that's going to change the thickness of this. Okay, this is the material browser. So I believe we have it selected. Concrete cast in place, double click. Concrete cast in place, change the thickness to 0 feet, right? 6 inches. It automatically checks structural member. That's the structure layer with a cut hierarchy of 1. Remember? 1, 2, 3, 4, 5. They have cut hierarchies, just like the walls. Structure, substrate, thermal air layer, finish 1, finish 2, membrane layer, structural deck 1. So as you can see, and you can install, insert other layers, just like in the wall tool. And again, it's only going to show us section. It's not going to show us plan. Unless it showed us the X-ray of it, which would be helpful for cutting with diamond-encrusted bits floor slabs, because they make mistakes, and they have to be cut out when they could have been formed out prior and saved everybody a lot of time and money. But who you back charge for that is all based on your relationship with your crew and your contractor. Whatever subcontractor, the general contractor selected, that's their problem. If you look at this from a perspective of so far up the corporate ladder, then that's a significant detail for someone to ensure that doesn't come to fruition. So shit rolls downhill. I have the luxury of dictating policy on this video. Not in life, in the imaginary world. I have the authority in the imaginary world. But the only thing worse than authority is the lack of authority. And I know that to be fact. So let's just keep this coordination meeting 70 degrees with very little barometric pressure. So we've done that. We've changed it to 6 inches. It's cast in place. Select row 3 and click the insert button. Well, that'll put layer 3 down, right? So there should now be 4 layers. Select the new row 3 and set its function to structural deck. Structural deck. Cut hierarchy 1. And you notice the changes more into a corrugated deck. Now, it doesn't say anything about changes materials. Select the new row 3 and set its function to structural deck. The new structural deck properties appear below the layers as shown in figure 14.6. And let me just take a look at 14.6 that you're not going to see, but I'll show it anyway. It's structural properties. Up here, well, the structural properties are right here. Form deck non-composite 2x6. Deck usage bound layer above. Now, if we just click on this structure here, you'll notice there's a difference. Let's see if there's a difference. No, this structure, cast in place concrete, is the layer above. Structural deck, it's a profile, which means, we talked about this, with the reveals and sweeps, how we create profiles and we sweep them around for interior molding, right? For the chair rail and for the crown molding and all of those beautiful things. But it's the same concept. It's the same concept. It's a profile. Now, and you can probably, not probably, but there are more profiles to load. Now, before we go off on that direction, let's continue with the value for deck profile should be default to form deck non-composite 2x6, 2 foot by 6 inches, I should say. Or M-form deck, non-composite 50 by 150 millimeters if it was in metric. Once you confirm this profile, click OK for the edit assembly and type properties dialog boxes. We'll click OK. Doesn't say material, that's okay. OK. And OK. In the dialog boxes. Floor, structural slab. Let's take a look at some of the properties within there, and I'm not going to get into it, but you just take a look. You'll see that everything you need for now in the early phases can be ascertained. This is what we're looking at. We're looking at, well, before we get into this, so how much? Do you how much? I have all the time. How in the hell are you going to be able to do this? Persistence of tools. You have to. When you're a tenancy and sufferance down at Suffragette City. So, we're good to go. If you do not have a structural deck profile loaded, finish the floor by selecting Finish Edit Mode. Then, that would be here. Then, select the Insert tab of the ribbon and click Load Family in your default Autodesk Content Library. Find the Profile folder, Profiles, and open the Metal Deck subfolder. Pick an appropriate deck profile and click Open to load it. Select the structural slab floor and click Edit Type in the Properties palette to continue this exercise. Okay, well, let's indeed see if we can load this. Well, we can't load it from here. It is already loaded. We don't have to necessarily look and import a profile, so we're going to change it. Let's see if we can change it when we're done. So I'm just going to finish, cancel. So now, if you select it, the floor structural slab has indeed been modeled in. Now, if we zoom down, you can see 3 inches. We talked about 3 inches, didn't we? We said 3 inches. Well, architecture, just check our math. So draw a model line in this direction, 3 inches. And I'm one of those guys that I like to double check things. So there's 3 inches. And if you remember, when we were placing this slab, we said offset it 3 inches from the, if you remember, the witness line, for lack of a better term. The mullion interface, right? The mullion interface. Because there is the curtain wall. Location line. Location line. All right, so that holds true, and that's the most important aspect, or at least I shouldn't say the most important aspect, but that's important to know right off the bat. I know there's a method to my madness. So if you don't have a structural deck profile loaded, finish the floor by selecting Finish Edit Mode, then select the Insert tab on the ribbon. Well, you can do it from here, and if you have the luxury of inserting anything here. If you're in a tab and you try inserting things, sometimes you can get a message that it's not appropriate to load anything from that tab because it's not in the right category. So you have to be kind of cognizant of that. Insert usually takes care of all that. It doesn't. It's really not tab tool discipline specific. So that's going to help us with this particular exercise. So if you don't have a structural deck profile loaded, finish this floor by selecting Edit Mode, then select the Insert tab of the ribbon and click Load Family. In your default Autodesk content library, excuse me, in your default Autodesk content library, you'll see it goes, this isn't the default library, remember, it's in the root directory. It's under the program data, which is hidden. And again, I can tell you this a million times, it's under Autodesk, and it's under RVT 2020, and libraries, US Imperial, profiles, metal deck. Well, as you can see, we have a few. We have a non-composite, roof deck, deck composite. Now, all they are 2D profiles. They're just 2D simple lines that are extruded, basically, and repeated in patterns, just like we saw on the curtain wall. They're patterns. All right, so dovetail rib, that's always nice. Nothing like a dovetail. Nothing like mourning doves in the morning. Okay, so if we wanted to, we could load other profiles and give this deck appearance a different look. And if you want to demonstrate that, I'll give you the option of having an additional profile so that we can test the software platform. Let's not be lazy about it, right? If it made a point to check to see if the tool works, then I would advise doing it. So, where was I? I'm in Autodesk, and I go down to REVIT 2020, to libraries, to libraries. There's no libraries, only strawberries, blueberries. None of that. Profiles, and blended swept, you remember? All these beautiful things that we created before. Anyway, metal deck. Dovetail rib, I'll load. Actually, you may be able to load more than one. We have this one. I can choose an option to overwrite. And sometimes it allows you to load lots of them. In this case, it may let us load all those. So in theory, I don't want to overwrite the existing version. So I'll cancel that. Let's see if let me bring in the ones that aren't composite. Let's bring in this one, bring in this one, and this one, so we don't overwrite the existing. Usually I get a skip. Non-composites already exist in there. Now we didn't see those when we pulled down. Let's just double check. If I was to select the floor, go to the type, and go to the edit assembly, and take a look at the number 3, deck composite. Well, I only see the one that's in there. I don't see how we can add one. Maybe it'll be revealed further down the chapter. So, hold that thought, and let's just take a look here. Nope. Hold that thought. I don't see that parameter just yet. So hold that thought. Okay, open the structural tab, edit assembly. Maybe this is where they're going to reveal it to us. Activate wall section 1. And you should see the completed slab at level 3. Okay, well, it wants us to open this, but then it wants us to activate the section. So, activate wall section 1. Wall section 1. Ah, okay, good. So, let's come over here and take a look at it. See if indeed there's a no template is assigned to this view. View name wall section, level 3. So if we take a look at that detail, this is a simple detail. I want to just look at the settings, visual style. Hold on, make sure that. Okay, so that's the fine setting for this display. That's the medium, and this is the coarse. If you choose to take it, so let's put on coarse for a second. Let's just take a look at some of the components that make up this this structural slab. So, as you can see, we're to now edit the assembly of the structure. Notice that you do not see the details of the structural decking when detail level is set to coarse. If you activate the callout at level 3, detail at level 3, you will see the structural decking because the callout's detail level is set to medium. The difference is illustrated in figure 14.7. Remember with callout views, we talked about this. If you have the callout view set independent of its parent, you can change those parameters like scale and visualization settings. But if it's dependent on the parent, then it's going to inherit those same view properties. So just remember that that's going to be an independent view. So I'm just going to cancel that here for a second, do what it says. Here's the call out. Right mouse click, go to view. It's already on medium. And we take a look at it. So, again, this is the curtain wall with its location line, right? With its location line. And its finished face is 5 inches from it. The mullion is 5 inches from the location line. Again, you know me. I'm going to make sure that's just how we have to do it. Click to get dimensions. You click the annotate and you click the aligned and you can click between 2 points. Now you have to click outside of, you can't pick anything else or it's going to continue it as a baseline dimension. So, and again, in this half-inch scale, if you put this on a drawing, that might not be very aesthetically pleasing. You might want to keep all your text a bit smaller. Now, at a half-inch scale, which is 24, 1/8 inch scale, 1/8 inch text, you have to do the math. It's the golden ratio, right? If you're at 1/8 inch scale equals a foot, and you want to have your text at 1/8 inch on your paper, well, the text has to be 12 inches. And it's the same concept here. if this was an 1/8" scale, and I'm going to go back, if this was an 1/8" scale, and I wanted my text at 1/8 of an inch, I would have to edit the text. But that's how AutoCAD works. That's how AutoCAD works. In Revit, there are no dynamic attributes. I mean, there are dynamic attributes for text, but it does it for you. If it's defined as 3/32 of an inch, then it's going to be 3/32 of an inch, irregardless, and it's going to stay there despite the scale. I know it appears that way, but on the paper you'll see it'll inversely proportion itself for that. So as you can see, as you go up and down the scales, you'll get something that's more aesthetically pleasing for your viewing of it on this view. And when you get it on paper, you'll see. When we drag it to a sheet, I know it's a little bit flexing, but you'll have to study standard annotation, scaling parameters on your own time. But that's generally the gist of it. So I know I went off on a tangent, but we're almost coming to the end of this particular passage. It's only a few paragraphs. But yeah, we can see the completed slab and the detail levels at the course. So just go back and undo everything and get it back to its original state. Zoom out a little bit. And if you activate the call out of level 3, blah, 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 you see the structural decking. The difference is illustrated on the screen. Now, it talks about cantilevered metal decking. You can see the metal decking profile shown in a section view. However, when metal deck runs parallel to a support member, the decking cannot cantilever as shown by default when you model a floor. You must customize these slab edges to show a more accurate representation of the decking condition. One easy way to accomplish this is to use the cantilever option when you're creating and editing the boundary lines of the floor. If you're using a floor type that includes a structural deck layer, select any of the boundary lines and you will see a cantilever setting in the options bar. If you define the boundary line at the center line of the supporting member, define the cantilever value for the steel to be 0, or 0 millimeters, and concrete to be the value appropriate to your engineered design. Sometimes these values may need to be negative distances to achieve the desired cantilever condition. When you finish the sketch and observe the slab edges in the section view, you will see a more accurate representation of the appropriate construction technique for the floor element. Now, that's a lot that's going to require that we edit the lines of this particular floor, and we're going to cancel. We have to tile our views. For starters, we have ZA, and we're going to go back to our project browser, and we've got to go to level 3. All right? Go to level 3. I can do it right from here if I select it. Well, there's the floor. If I want to edit the boundary, I'll get those pink lines again as we pick the walls. So if I select one of them, cantilevers concrete in the options bar, cantilevers concrete, cantilevers steel. Extend into wall to core, define slope, offset. We've only touched on the one parameter within the transparency of invoking the command. Obviously, as you can see, there are more variables and parameters that we can constrain and assign properties to. I think I'll stop this video there. I think it's giving you a pretty good, quick overview of the methods and the methodology. Even though mythology plays into this. We can start talking about the orders of architecture, but let's not get into that. What hat are we wearing today? Are we wearing the structural hat, the architectural hat? What hat? How many hats? How many hats do I have to wear? In any event, this is the gist of it. So we're right on the cusp. Stay focused. Save this for posterity and remember me fondly.